Alright, I'm going to talk to you about transversals and angle relationships and parallel lines. This particular section of the unit is very heavy with vocabulary and that you really need to understand what the words mean. You need to understand and be able to give examples of the words. And the purpose of it is that once you understand the relationship between the lines and the angles, then you can use that knowledge to help you determine missing angle measures. And so just to review, adjacent angles are angles that are side by side and they share a common ray. And so this right here is the ray. A ray is in the middle of the two of them. It does not matter what the angle measures are. They don't have to have a specific sum. It could be 5 degrees and 10 degrees. It doesn't have to be any specific angle measure. These are examples of adjacent angles. As you can see, they have all sorts of different numbers. They have all sorts of different sums, the pair of the angles. But the key is that they are side by side. These are not adjacent. These are angles, but they're not adjacent. They're next to each other, but they do not share that common ray. So when you see angles like this, they are near each other, but they're not considered adjacent angles because they don't share a common ray. Now, when two angles that are adjacent have a sum of 90 degrees, they are called complementary angles. And so when you think of a 90-degree angle, that's also a right angle. And so they're two angles that together would form a right angle. So it could be 50 and 40 degrees, it could be 45 and 45, it could be 89 and 1. But just that two angles that have a sum of 90 degrees. These two angles you can see equal 90 degrees, and then of course these two angles you can see equal 90 degrees. Supplementary angles have a sum of 180 degrees. And so what we can do is we can use this to help us figure out missing angle measures. So for example, with this one right here, this is 36 degrees, and we don't know this missing angle measure right here. We could call that x. So we know that the two of these angles together equal 90 degrees. So to solve that, we're going to isolate the variable by subtracting 36 from both sides. And I'm showing you algebraically because they're going to get a little bit more challenging. I know this one you may be able to do in your head, but they're going to get a lot more challenging to where you're going to have to really write out the steps and follow through with the solving equation process. So I'm going to subtract 36 from both sides. That's the way that I'm isolating the variable here. So I've got x is equal to, and then 100 minus 96 is 54. So this angle measure right here, this missing angle measure is 54 degrees. Just the proof. All right, down here, we can figure out the angle measure, but for this particular problem, I want you to figure out what x is equal to. So again, we use the fact that the two angles together are equal to 90 degrees because they are complementary. So 42 plus 2x is equal to 90. So to solve this one, this is a two-step equation. So I'm going to have to do, I'm going to have to subtract 42 from both sides. So we are doing reverse PEMDAS. You do the adding and subtracting first when you're solving equations, and then you do the multiplying and division. So we're going to subtract 42 from both sides, leaving us with 2x is equal to, and then I've got 90 minus 42, which is 48. So that missing angle right here, it's 48 degrees. But if I want to solve for x, I'm going to divide both sides by 2. And so x is equal to 24. Alright, here we've got two angles that are supplementary. And so we know that 168 plus this angle measure here, we'll call this x, together equal 180 degrees. So x plus 168 is equal to 180 degrees. So I'm going to subtract 168 from both sides. And when I do that, I am left with x is equal to 180 minus 168 is 12. So that this missing angle measure right here is 12 degrees. For this one, I know that these two angles together are equal to 180 degrees. So but this time I want to solve for x. I'm not figuring out the missing angle measure. I want to solve for x. So I've got 4x plus 134 is equal to 180. I subtract 134 from each side, leaving me with 4x is equal to 46. Then I'm going to divide both sides by 4 because remember I want to isolate the variable here. I want to get it by itself. And this leaves me with 11.5 or 11 and a half. So x is equal to 11 and a half. And this angle measure is equal to 46 degrees. That's what we were able to figure out right there. The next word is vertical angles. Vertical angles are opposite of one another, but what's important to realize is that vertical angles have the same angle measure. So if this is 100 degrees and this is 100 degrees, we can use that to help us figure out these angle measures. This must be 80 degrees because these two angles are supplementary, and then if this is 80 degrees, this must also be 80 degrees. And then again, you can double check because these should be equal to 180 and these should be equal to 180, which it does. It works out that way. So here, we've got a transversal, and a transversal is what intersects a pair of parallel lines, and it intersects at one place on each line. It's not curved, it's straight. It's a straight line. And what happens when there is a transversal that intersects a pair of parallel lines, this is the symbol for parallel, showing that L and M are parallel to each other, it creates 8 angles. Excuse me. And so if I know that one angle, just this one right here, is 120 degrees, I can determine that this angle is 120 degrees because of vertical angles. Now in class, we folded up the paper and we cut it up and we set it into piles showing which angles were equal when we cut it up. And from that you were able to see that, that all these angles were equal to 120 degrees, that there were 4 angles equal to one number, and then there was another 4 angles equal to another number. In this particular example, if these are each equal to 120 degrees, that means that each of these must be equal to 60 degrees because of supplementary angles. So if this is 60, then this one is 60, this one is 60, and this one. They're all 60 degrees. Those 4 are 60 degrees. And here it is, just a nicer handwriting, or nicer print than my handwriting. So now we're going to talk about the words that get a little bit more confusing, okay? You've got alternate interior angles, and if you look, this is considered the exterior, and this is considered the interior. If you think about the interior of a house, it's what's inside the house. So the parallel lines, what's inside the parallel lines is the interior, what's outside the parallel lines is the exterior. And then of course you've got your transversal here. Alternate interior angles are alternate, meaning they're opposite from each other, and they are interior, meaning they are on the inside. So they are angles that are on the inside of the parallel lines, and they are opposite from each other. So these two pink ones, they are alternate interior angles, and these two blue ones are alternate interior angles. For alternate exterior angles, again, remember this is exterior here on the outside. So alternate meaning they are opposite from each other, and they're exterior, they are outside, and they are angles that are opposite on the outside from each other. Corresponding angles simply have the same angle measure. Oh, and I should say too that with alternate exterior, they have the same angle measures. And same thing with alternate interior, they have the same angle measures. Corresponding angles have the same angle measure, and if you could imagine just sliding this pink piece down to this pink piece, they have the same angle measure. The purple would slide down to the purple, they have the same angle measure. Blue slides down to the blue and has the same angle measure, and the green slides down to the green and has the same angle measure. So corresponding angles are congruent to each other, meaning that they have the same angle measure. Two more words, or two more terms that you need to be familiar with are same side interior angles. And when it says same side, it means same side of the transversal. So here, the picture got kind of cut off, but these are lines right here. These are your parallel lines. And this visual does a good job of showing you, here's your exterior, and then your interior is the purple here in the middle. And then this red line is the transversal. So when I see same side interior, it's interior, so I know it's on the inside. And when it says same side, it means same side of the transversal. Same side interior angles have a sum of 180 degrees. So angle 4 and angle 6 together, they're the same side interior angles. They have a sum of 180 degrees. Angle 3 and angle 5, they're on the same side of the transversal, so they are same side interior angles with a sum of 180 degrees. Same side exterior angles, again, here's your exterior in the blue. They're the same side of the transversal, so 2 and 8 are on the same side of the transversal. Together they have a sum of 180 degrees. And then 1 and 7, they're on the same side of the transversal, so these same side exterior angles have a sum of 180 degrees. So you can use that to help you find missing angle measures. So alternate interior angles is just saying if you have two pair of parallel lines that are cut by a transversal, then the pair of alternate interior angles are congruent. And so with all of this, just knowing from this, and this is the thing that you're going to use the most, this is saying that angle 4 is equal to angle 5. Well, angle 4 is equal to 5, so therefore 1 is equal to 4. Because we know those angles are vertical from each other, and then 8 is vertical of 5, so those two angles are equal to each other. And then 3 and 6 are alternate interior angles, which means they have the same angle measure. 3 is vertical of 2, which means they have the same angle measure, and 7 is vertical from 6, which means they have the same angle measure. So all the greens have the same angle measure, and all the yellows have the same angle measure. Alright, so now we can use that to help us solve for variables if we're figuring out angle measures. So for example, with number 1, because of alternate interior angles, these two angle measures are the same. So that means that 80 degrees, that does not look like 80 degrees, 80 degrees is equal to 2x. And I divide both sides by 2, and so therefore x is equal to 40. This doesn't mean that this is 40 degrees, that means x is equal to 40, so this angle measure is still 80 degrees as well. With number 2, if this is 120 degrees, this side is 120 degrees, and so I say 3x is equal to 120 degrees. I divide both sides by 3, and I get that x is equal to 40. Again, this doesn't mean this angle measures 40 degrees, simply that x is equal to 40 degrees. And then here with number 3, we have 100 degrees for this angle, and so these two angles are the same. They have the same angle measure, so 100 degrees is equal to x minus 10. So I'm going to add 10 to both sides. And when I do that, I'm left with 110 is equal to x. And again, that doesn't mean this whole angle is 110 degrees, just the solution to the equation right here. X is equal to 110.